All right, let's just dive right into this one. Welcome to today's Explainer. We're looking at what you could genuinely call a tale of two titans. We're going to break down how deep learning architectures, specifically two massive rival frameworks, are absolutely revolutionizing modern national security. We're going to explore how machines are actually learning to see, to connect dots, and to strategize in ways that were, frankly, practically unimaginable just a decade ago.
I mean, the landscape of defense, it's shifted practically overnight. Our source hits the nail on the head here, noting that these deep learning algorithms have rapidly evolved from, quote, theoretical curiosities in academic papers to absolutely indispensable tools across the real-world battlefield. So yeah, we're way past hypotheticals now. We're talking about actual, real-world survival and strategic dominance. Okay, so here is our flight path for today. We'll start with the AI defense revolution, then meet our two titans, CNNs, the eagle eyes, and transformers, the master connectors. After that, we'll check out the hybrid AI advantage, and finally wrap up with the ethics of human-machine teaming. Let's get to it.
Part 1. The AI Defense Revolution.
To even understand why we need these algorithmic titans in the first place, you've got to look at the sheer scale of the problems military commanders are facing today. The modern battlefield generates an incomprehensible amount of data. We are talking high-resolution satellite imagery, continuous radar pings, massive volumes of comms intercepts, and acoustic sonar data. A human being simply cannot extract meaning from those massive, complex, real-time data streams fast enough on their own. It's impossible. We need machines that don't just see the data, but actually understand it.
Which brings us to Part 2. CNNs, the eagle eyes. So when it comes to visual inspection, convolutional neural networks, commonly known as CNNs, are pretty much unparalleled. To understand how these eagle eyes work, you actually just look at the biological visual cortex. A CNN relies on what's called a receptive field. Basically, it restricts its focus to a tiny, localized chunk of data. It slides this mathematical filter over an image, finding simple edges, then maybe textures, then more complex shapes, building up this spatial hierarchy. It's like a hyper-focused inspector learning exactly what visual patterns to hunt for. And because of that hyper-focused vision, well, CNNs act as the ultimate visual inspectors out there on the battlefield. They are incredible at image recognition, like spotting a specific type of military vehicle in a really noisy satellite feed. They handle change detection perfectly, right? Like noticing if a landscape got altered by covert troop movements overnight. They can guide autonomous UAVs through crazy complex terrain and even analyze electromagnetic radar signatures. Essentially, they know exactly what is out there and exactly where it is. But you know, every Titan has an Achilles heel. CNNs struggle with long-range dependencies. Because they rely on those fixed receptive fields we just talked about, they kind of suffer from tunnel vision. They are fantastic at analyzing the details right in front of their nose, but they really struggle to connect dots that are spread far apart. Like if a clue is on the far left side of an image and a related clue is way over on the right, a CNN might just completely miss the connection. All right, Part 3. Transformers, the master connectors.
If CNNs are the eagle eyes, transformers are the master connectors, and they completely, totally shifted the AI paradigm. Instead of scanning small chunks sequentially like a CNN does, they use this thing called the self-attention mechanism. This is a huge breakthrough. It lets the AI dynamically weigh the importance of every part of an input sequence at the exact same time, no matter how far apart they are. Basically, it looks at the whole board at once and sees how every single piece, whether that's a word in a document or a patch in an image, relates to the whole shebang. So what does that relational superpower actually look like in practice? Well, transformers are basically perfect at reading the room. They can chew through just massive amounts of text for intelligence extraction and summarization. They do sentiment analysis on intercepted comms to figure out an adversary's intent. They can literally read complex malware code to understand what a cyber attack is actually trying to achieve. And they can fuse together multimodal data, like taking a text report and combining it with a radar feed to find the hidden meaning. So let's put them head-to-head for a second. CNNs have a spatial bias. They efficiently scan pixels to tell us the what and the where. Transformers, on the other hand, have a relational bias. They use some heavy computing power, what we call quadratic complexity, to tell us how things relate, giving us the big strategic picture. Think of it like this. One is unbelievably good at looking at the trees, and the other is uniquely built to understand the forest. Moving on to Part 4, the hybrid AI advantage. Now, this is where modern defense gets genuinely exciting, because the future of defense AI, it is not CNNs versus transformers. No way. It is CNNs plus transformers. These titans aren't just rivals. When you combine them, they form this ultimate dream team, leveraging the local visual focus of the CNN and the global contextual awareness of the transformer. Let's look at a real example. Imagine trying to spot a heavily camouflaged tank in a super chaotic battlefield environment. Step 1. The CNN acts as the feature extractor, perfectly picking out these really subtle textures and edge patterns that, to a human eye, would literally just look like bushes. Step 2. Instead of stopping there, it feeds those detailed features over to a transformer, which grasps the global context and how those shapes are arranged spatially. Step 3. The combined system definitively flags the tank. It defeats the camouflage in a way neither architecture could reliably pull off on its own.
Or consider this timeline for intercepting a complex enemy plot. In mere seconds, a transformer processes raw, intercepted enemy communications, picking up on semantic intent and shared jargon hidden in the text. Over the next few minutes, a CNN analyzes the structured metadata, looking at patterns in things like timestamps and sender-receiver frequencies. Within hours, the hybrid system links the what and the how, successfully flagging an impending coordinated attack. It's an absolutely incredible synergy.
Which brings us to our final section, Part 5, Ethics of Human-Machine Teaming. Of course, with immense power comes some pretty profound implications. Think about this. If an AI-driven system, processing data way faster than any human ever could, recommends a critical strike, who is ultimately accountable? Is it the human commander who signs off on it? Is it the developer who wrote the algorithm? Or is the machine itself actually making the choice? Navigating this chain of responsibility is honestly one of the most pressing challenges in modern defense today.
Furthermore, how do nations navigate an AI arms race? While powerful nations obviously have the resources to build these advanced hybrid models, the proliferation of AI tools empowers smaller, non-state actors as well. This technology levels the playing field in some highly unpredictable ways, completely shifting the landscape and the threat of asymmetric warfare.
And then, there is the intense debate around lethal autonomous weapon systems, or laws. Can an algorithm truly understand proportionality and necessity in combat? People are raising really valid arguments here regarding the risks of algorithmic bias and the genuine fear that delegating life or death decisions to machines could lead to unintended escalation or violations of humanitarian principles.
Now, these ethical hurdles lead directly to a massive technical challenge, which is the critical need for explainable AI or XAI. Basically, how do we verify and trust a black box model? Because if a complex transformer makes a massive intuitive leap to identify a threat, human operators absolutely must be able to understand why it made that specific recommendation. Without transparency, human trust in these high-stakes environments, it's pretty much impossible.
So we're going to leave you with this final, lingering question today. In a future driven by hybrid AI, where these eagle eyes and master connectors are acting as teammates rather than just tools, how will humanity maintain control over the very nature of conflict itself? It is a fascinating, complex, and incredibly urgent reality to consider as we move forward. Thank you so much for joining us for this explainer, and we'll see you next time as we continue to unpack the ideas shaping our world.